Hello students. So now we'll be seeing about the last part of Unit 2. Here today we'll be seeing about digital switches and electromechanical switches in detail. I'll give you a basic introduction about switches. So we'll see with the basic concepts of analog signals and digital signals. Here we'll see the analog signals. So analog signals are designed to pass or isolate an analog signals. For example, we can say CD4066B. So we call it a COMS quad bilateral switch. So that's a kind of analog switches. And considering the digital switches, it's very discrete, changing in specific steps to represent digital information as zeros and ones. So we know we have two foundational type of signals. One is analog and one is digital. So both are used to transmit information, but they can be done in different ways. So you know basically what is analog signals. So analog signals are continuous. Every time it changes smoothly over time. And moving on to digital signals are discrete, changing in specific steps to represent digital information as zeros and ones. So analog signals are often visualized as sine waves, while digital signals are typically represented by square waves. So analog switches are designed to pass or isolate analog signals. So they essentially route analog signals based on a control signal. So analog switches can exhibit decent performance with digital signals as well. So they function similarly to relays, but without any moving parts. So they are also known as bilateral switches because they allow signals to pass in both directions. So when you consider bilateral switches, they allow signals to pass in both directions. So analog switches are available in various packages. So it includes through hole and surface mount technology. And considering the specification of analog switches, whenever you select an analog switch, we have to consider some specifications. For example, first we can consider on resistance. So nothing to confuse with on resistance, but on resistance is nothing but the resistance between the input and output terminals when the switch is on. Okay, so on resistance you have to understand the resistance between the input and output terminals, right? So when the switch is on, you have to focus on that. So typically in the range of few hundred ohms. So now we have learned about on resistance, and the next thing is off resistance. So this is the resistance between the input and output terminals when the switch is off. So you have to identify when the switch is on, when the switch is off. When the switch is on, it is on resistance. When the switch is off, it is off resistance. So typically when you consider off resistance, it is the mega ohms or giga ohms range. So signal range, considering the signal range, the range of voltages from minimum to maximum that can be passed through a switch. So the injection of a small electric charge into the signal when the switch is turned on, it causes a small spike, or we can call it as a glitch. So this switch ability to block signals when it is off. So this we call it as feed through. So parasitic capacitance can allow higher frequencies to pass through, making the switch appear to be in the on stage. Two types exist here. So one we call it as crosstalk between switches. So control enable to output crosstalk, and crosstalk between switches can also be possible here. So this refers to control the signal input. So the input can be decoupled from the switch output. So this is the basic things we have to see here. So we have learned about uh, on resistance and off resistance, right? So next we'll move on to digital switch. So digital switch is nothing but it is designed to pass or isolate digital signals. So we have some examples. So we call it as CBT and CBTLV. So this is the digital switches from Texas Instruments. So digital switches can also adequately pass analog signals, and it is used in computing applications for multi-bit switching, and there are so many wide range of applications in digital switch. So it includes multiplexing of USB terminal peripherals and Ethernet multiplexing. So this diagram represents the diagrammatical representation of a digital switch. So if you see in this diagram, we have switches. So here the figure depicts about the digital switch logic diagram. So we have multiple digital switches, so which is incorporated between input lines A1 to A8. So A1 to A8 are the input lines, and output lines are represented from B1 to B8, right? And these output signals is used to enable the switch in different states, that is on or off. So we have so many features to represent. So we have a switch type, signal type switch. So it operates mainly on digital signals. So basically we can specify the power consumption, whether it is high power or low power, and performance, and it can be based on speed, storage, etc., and based on cost also we can consider. So analog switches are more expensive, and digital switches are less expensive. And considering the storage, um considering the storage, analog is cannot be stored digitally with minimal space. So here it can be stored with minimal space, and based on the speed, analog is of lower speed due to analog components. So here it is a higher speed of operation can be performed. So the performance is low considering in analog switch, and in digital switch it is higher. So we can compare all these features with the analog switches and digital switches. So this is the diagrammatical representation of a digital switch. So here we'll be seeing about the operation of switches. So the operation of switches can be defined with two ways. The first type we call it as latching of switches, and the second we have momentary switches. So latch switches can also be called as maintain switched or lock switch. So both of these type of switches are widely used in electrical and electronics applications, where the selection of switch type depends on the system requirements. So we have to understand the system needs in which they are going to be incorporated. So switches can also be categorized on different basis and factors. So if you consider a latch switch, which is known as a switch which maintains its last state until it is automatically or manually forced to change the position. So for examples, we can say push to break, or a common example as a light switch, or push to make. So in short, we can call it as the last switch holds its states whether on or off until new commands are initiated. So that type of switches we call it as latch switched. So next type we'll go for momentary switch. So for examples here we can say electric drill, push down buttons in the blowers, for examples like push buttons. So these are considered to be an example of momentary switch. So this is a switch which maintains its state as long as the button is pressed or actuated. So when the pressure is removed from a switch, it returns to the previous state both in position and in operation. So in other words, we can say the momentary switch holds the state only when the specific command is presented. So these are the different types of switches we are going to learn. SPST, SPDT. So we'll be seeing in the later part the detail of all these type of switches. So we have rotary switch, timer switch, joystick switch, thermal switch, and so on. So we will be seeing one by one about all these switches in detail, right? Okay, so now we are going to see what is meant by electromechanical switches. Okay, so first you have to understand what is meant by an electromechanical switch. It is nothing but it operates by physical, which operates physically bringing two conductive plates. Okay, so both the plates come in contact with each other and it allows current flow and it separates them to interrupt the circuit. So mechanical switch is a switch in which two metal plates touch each other to make a physical contact for the current to flow through it and it separate from each other to interrupt the flow of current. Okay. So this tactile mechanism provides a reliable and intuitive means of controlling electrical connectivity. So there are different types of mechanical switches which can be additionally categorized based on power handling capacity, number of poles and throws. So there are different types. First type we call it as SPST. The second we call it as SPDT. The third we call it as DPST. And fourth type we call it as DPDT, and the fifth type we call it as DPMT, and we'll be seeing the different other types of switches. So these particular poles or the switches is based on some construction and operation, and we can have the number of contacts, holding states, etc. based on the types of switches. So mechanical switches are highly versatile and it can be classified based on several parameters. So considering the classification criteria, it can be handled or it can be classified based on power handling capacity. So where it determines the suitability for low voltage signaling or high power switching. So poles and throws. So here it defines the number of independent circuits and output paths. So we are going to see the different types of switches here. So first type we call it as SPST. So we call it a single pole single throw. SPDT is single pole double throw. SPDT is single throw double throw. So next we have DPST, so double pole single throw, and DPDT double pole double throw, and DPMT double pole multi throw. So the actuation and the construction includes toggle, so it can contain push buttons, rotary, and more. And there are number of contexts, so it can influence switching complexity and redundancy. And we have also holding state. So holding state can be considered as last or momentary. So it maintains, so last is nothing but it maintains position until it is manually changed. Momentary returns to default state after a release. So there are numerous applications for these electromechanical switches. So we have it can also be used in consumer electronics. So for industrial control panels we can use. So under automotive systems we have electrical switches, and under embedded hardware interfaces mechanical switches remain fundamental both in analog and digital systems. So it offers robust and tactile, and it also has a safe control access over a wide range of environments. So as I told you before, we have holding state. So last is the important state where it maintains position until it is manually changed, and we have momentary state where it returns to default state after a release. Okay, so we'll move on to the next slide. So here in this slide, we will be learning about SPST. It is single pole, single throw. So this is a simple on-off switch found in our homes, or we can see in a building, etc. So it is called a one-way or single-way switch. So so it controls single operation in a circuit. So it makes or breaks the circuit. Generally, the contact of SPST switch can be either no for off position or NC normally close for on position. So we have these representations, but for each and every type of switches, we'll be seeing a diagram. So you may understand more clearly if you see a diagram. So an open switch indicates a break in the circuit. So it means that it stops the flow of current in it. A closed switch represents the circuit is completed and the current is flowing through it. So it's a normal function of a switch. So yeah, so we'll see mechanical switches can be categorized based on the different factors, design and operation. So SPST switch is nothing but it's considered to be a basic on-off control. So this switch has one pole, so it controls a single circuit. So one pole is nothing but it controls a single circuit, and one throw is nothing but it connects or disconnects the circuit in a single path. So moving on to the working of this particular switch, um, consider a basic light switch. So on position and off position you have to consider. So the contact close specifies that allowing current to flow. If the contact is open, then it interrupts the current. Okay, so that is the normal operation we are going to specify in SPST. So, considering the features, it is very simple. So, ideal for basic on and off control. So, the design is very compact, often used in small devices or panels. So, considering the versatility of SPST, it is available in toggle, rocker. It can be used in push button, and it can also be used in slide formats. So as we can have other some common applications like LED control circuits. So these switches are very common in power switches for appliances, DIY electronics and prototyping, and we can also use it under automatic and industrial panels. So moving on to the next, before moving on to the next type, we will see what is meant by SPST. So in a diagrammatic representation, we can see this. So single pole, single throw. So the first figure represents it's in a off condition. So the circuit is not closed, so the current will not flow through it. And if you see the second switch, it is connected, so the current can flow through it, right? So the construction and working of an SPST is shown below, and this is a switch also known as one-way switch. Two-way switch in the US and Canada we call it as NEC or CEC. So yeah. Uh, so next we have SPDT switches, where we can consider that as single pole double throw. So considering single pole double throw, it has three main pins. So the pins are also called as terminals here, and then extra as a ground terminal. So the input terminal is known as a two-way switch. So here we can call it as three-way switch in US. The remaining two terminals are called travelers, or we can consider that as output terminals. Uh, Okay, so considering this SPDT, single pole changeover, and SPTT, we can call it a single pole center off or single pole triple throw. So SPDT is single pole double throw, where switches can be used. So what is versatile circuit selector is possible here. So this switch features have three primary terminals. So common input we have. So the central terminal is connected to either of the two outputs. So that is common input. Next we'll see the travelers that we call it as output. So these terminals receive the switched connection from the common optical ground. So next we have the ground terminal included in some designs for shielding, or it can be used for safety. So this configuration allows the switches to route a single input to one of two outputs. So it enables changeover operations. So it is very commonly referred as two-way switch in many regions. Depending on the functions, we have a dual circuit control, so which can toggle between two separate circuits or states. So basically, next we have selector capability. So this we have to choose between modes, or we have to choose between sources or outputs. So mechanical form factors are also included here in this type of switches. So available as toggle, slide, rotary, or push button types. So moving on to some applications where we will be using SPDTR, light switching from multiple locations. We can go for mode switching in embedded systems, audio source selection, and we have control logic in automation plane and so on. So so this sample circuit diagram, if you are building something hands-on, then it is very useful. So light switching is done from multiple locations, and it can be also implemented in embedded systems and in automation panels. So moving on to the diagrammatic representation of single pole double throw. So this is the representation. So we have single pole double throw representation. So this is the switch type. So next we'll move on to the next type called as double pole single throw. So DPST switch is basically two SPST switches. So you have already learned what is SPST. So switches in one packet and it can be operated by a single lever. So SPST is a double pole single throw switch. So where we can have double circuit control with unified action. So basically, if you consider DPST switch, so this switch integrates with the two SPST switches in a single unit, and it allows both to be operated simultaneously via one actuator. So examples we can have lever, toggle, or push button. So moving on to the characteristics of this DPST, we have two poles. So it is independently controllable with two separate circuits. So we can have typical. We can say that we have typically hot and neutral lines. So single throw is also possible here. So for both circuits are either on or off. So on is closed, or off we can represent as open. So we don't have any intermediate states here for single throw. So considering the unified operation, in the consideration of dual line systems, it ensures synchronized switching. So this synchronized switching can make it ideal for isolation, or it can be used for energizing dual line systems. So this switch is mostly used where both ground and line need to be broken at the same time. So in short, it has two poles and it can control two circuits. So two circuits, it can consider it can be we can be saying that as hot and neutral. And a single throw we call it as it can make one operation whether either on or off. So we have seen some instruction about this DPST. So commonly it is used where both line and ground must be interrupted for safety, or it can be used for compliance. So it operates similarly to a two-pole circuit breaker. So it also provides reliable disconnection of both paths. So considering the applications of DPST, we can use these switches in industrial machinery power control. It can also be used in safety critical installations requiring full isolation, and we can also use this in HVAC systems, high voltage appliances, etc. So next, we'll be seeing about the DPST double pole single throw switches. This switches has four terminal pins. So here two is kept for input and the other two is for output. So DPST switches are used to control a single circuit. So normally we'll be using DPST to control a single circuit while both the contacts are needed to be actuated. Okay. So for example, a DPST switch is used to break both the line and the neural wire for the on and off operation of the connected device to it. So both the contacts are open in case of off position, so while both contacts are closed in case, then we can consider that as on position. So in other words, we can say as if either switches on or off, the two circuits can be used at the same time. So this figure shows the working operation of a double pole, single throw switches. So it is rated from 120 to 277 volt, so which makes or open both contacts via single operation. So these are the basics about DPST. So used to control a single switch while both the contacts are needed to be actuated. Okay. So next, we'll be seeing about DPDT. So DPDT is double pole double throw. So this switch is equivalent to two DSPDT switches packed in one unit. So here in this switch we have two common pins and four signal pins. So you have to understand we have totally of six terminals. So total four different combination of signals can be applied to the input pins of this switch. So another switch related to DP-DT is DPCO. So we call DPCO as double pole changeover or double pole center off. So this is the exact diagrammatical representation of DP-DT. So DP-DT is has two common pins and it has four signal pins. So here, this switches function as two SPDT switches. So these switches housed within a single unit is used very often. So it features six terminals. Already I told you, for two for common pins and four for signal pins. So it allows four distinct switching configurations across its inputs. So this makes it ideal for application and it can be used for dual circuit control. So when you consider DPCO, that is double pole changeover switch, it is also known as double pole center off. So considering the standard DP-DT, the DPCO includes a central off position, so it also enables both the circuits to be disconnected simultaneously, right? So this process is useful for added safety or for idle states in control system. So DP-DT switches are used commonly with two different electric circuits at the same time. So while it has a common lever for both operations, it can be used for two different operations. So uh, in spite of two different operations, it can be used for on and off positions. So next we have two pole six throw and two pole multiple throw. So that can be represented as 2PMT and 2P6T. So this DPMT stands for double pole multi throw and we call it as 2P6T. which is abbreviated as two-pole multi-through switches. So the exact representation of the diagram is shown below. So you can check this diagram. So double pole. So if you see the diagram, we can understand it has a double pole multi-throw, and 2P60 represents two poles, 6 throw. Okay. So if you count, you will be able to understand that concept. So these kind of switches consist of two poles and consist of a multi-throw, that is, it can be used to control two independent circuits. So by this figure you will identify what is an independent circuit, right? So these type of switches with a common lever are used as changeover and selector switches for multi-way switching. So these switches are versatile and it can be used for electrical components designed to manage two independent circuits simultaneously. So this pole represents the separate circuit path, while the multi-through aspect allows each pole to connect to multiple output terminals. So these switches typically refer or feature a single lever or an actuator. So that basically controls both the poles in unison, and it makes ideal for changeover operations. So already I have told you about the changeover operation. So it is nothing but it is a switching between different power sources or signal paths. So we will be focusing on the selector functions. So it is nothing but choosing among multiple outputs or performing configurations in a system. So such switches are commonly used in a multi-way switching setups where flexibility and control over multiple connections are also possible. Okay, so especially in common electronics, we can use it also in audio routing. It can also be used in industrial automation systems and so on. We have to understand DPMT. So we have selector functions, changeover operations that can be performed in DPMT. So we call it as double pole multi-throw switches, or we can say as 2P60, abbreviated as two-pole multi-throw switches, right? Uh, so moving on to the next part, we have rotary and selector switches. Uh, a rotary switch may have multiple poles, okay, and it has throws for different circuits. So selector switches are also called as rotary switches with a knob, so which rotates around its axis and switches and connects the common terminal to many of the output terminals. So the selector switches are available in different ways. So we can say IP12 way or 2P6 ways. So 2P6 ways are represented as 2P60, and we also have 3P4 ways, and we have 4P3 ways, etc. So these are the selector switches which with different ranges, and it has multiple moving and other contexts where the rotating knob is used to divert the switching operations of the switch from one to another. So the first in the left hand side we can see a selector switch, and in the right hand side it is a rotatory switch. This is same as a knob switch in the digital or analog multimeter. So this is based on the working principle of demultiplexer. So it is considered as electronic measurement tools and metering, where radio band selectors, channel selectors are used in a communication system. This is all about uh, rotary and selector switches. So we have possible selector switches we have already used. So selector switches are a type of rotatory switch, so which can be connected with a knob, and it rotates around the central axis. Whenever the knob get turns, so it is connected to a common terminal, and to one of the several output terminals it is connected. So it enables the user to select among multiple circuit paths or It can be connected with the different configurations. So these switches operate on different principles, which is similar to demultiplexer. So it directs single input to multiple outputs. Um, so based on digital and analog multimeters, it is used for selecting measurements mode like voltage, current or resistance. And we have electrical metering and instrumentation. Where we can use toggle between different sensors or input channels. Based on the radio band selection, it also allows users to switch between frequency bands. Uh, so, so we have learnt about all these band selection, etc. And moving on to the communication system, we have a reliable switching mechanism. So, as channel selectors for the routing signals are considered, this particular design and reliable switching mechanism can make them ideal for measurement tools. So not only for measurement tools, it can also be considered for control panels, and it can be considered for signal routing applications where clarity and precision are essential. And moving on to the next part, we have intermediate switch. We call it as four-way switch. So intermediate switch is also known as four-way switch in the US and three-way switch in the UK and EU. So we have learned. So it has four terminals which are used to divert the flow of current from one position to another. So these switches are used to control a single appliance. Okay. These switches feature four terminals, allowing them to redirect the flow of current between different pathways. And Typically, if you consider the conjunction with two-way switches, it creates flexible lighting control setups. So that's the main advantage here in using this type of intermediate switches. So here we have some varying applications where we can use intermediate switches. So this type of switches can be used in staircase lighting. So the control light from both the top and the bottom of the stairs can be specified. So hallways or large rooms, so it can operate a single light from uh, both a top and bottom of the stairs. So we have large rooms or halls. It operates on a single light from opposite ends. So multi-point switching can also perform commercial spaces where it can require convenient access to control the lightings. So here we also have intermediate switches. So it provides a multi-way switching. It provides configuration. It also enhances both convenience and energy efficiency in smart or traditional electrical systems. So these switches are used to control a single appliance, such as light bulb, point from different locations. For example, to control a light bulb from two different locations or simply a staircase, we can use these configurations. So next we have intermediate switch, four-way switch. So already we have seen this. So this is the diagrammatical representation. So position A we have 1, 2, 3, 4, and position B we have 1, 2, 3, 4. So these are called as intermediate switches. And at the right hand side we have changeover switch. So this is the exact representation of a changeover switch. So an intermediate switch is commonly referred to as four-way switch in the US, and it is designed to enable control of a single electrical load. For example, we can say such as a light bulb from multiple locations. So these features have four terminals. So these four terminals allow them to redirect the flow. Uh, yeah. So it redirects the flow of current between different pathways. So they are typically used in conjunction with two-way switches. It creates flexible lighting control setups and so on. So when you consider the applications for intermediate switch, we can have staircase lighting, so which controls light from both the top and bottom of the stairs. And considering the large rooms and halls, so it also creates a single light from opposite ends, right? So intermediate switches play a key role here. So we have multi-way switching configurations, so it also enhances convenience and energy efficiency in smart or traditional electrical systems. So we have seen in this diagram what is an intermediate switch and a changeover switch. And next we'll move on to toggle switch. So it's a very different type of a switch, where toggle switches are latch type of switches which are actuated by a lever angle in one or more directions. So if you see the representation in the figure, you will be able to understand how the lever is handled in one or more directions. So this switch is stable, and it remains in that state unless or until the lever is pushed in another direction. So the user had to handle this particular toggle switch. So most of all household applications such as lighting control switches have toggle switches, and it fall into any category which is mentioned here. So SPST, SP, DPDT, DPST, DPDT and so on. So there are highly available current applications where they have used 30 plus amperes, and it can be used for small current switching operations. So the rating change and design may vary depending on the circuit requirements and appliances. And applications. So the design may vary depending on the circuit requirements and applications. So the toggle switches are a type of latch switches. So it can be operated by a lever, so that moves in one or more directions. Once when the switches is actuated, so it maintains a position remaining in a stable state. So until the lever is manually flipped to another position, this latching behavior makes them ideal. And this type of applications where there is a persistent on or off or directional state can also be considered here in toggle switches. So considering the features, we have the mechanical stability for this particular switch. So it holds state without continuous user input. Depending on the operation, it has simple lever based actuation which is very easy to access. Moving on to the versatile configurations, we have available forms such as SPST, SPDT, DPST, DPDT. So depending on the number of poles and throws, we'll be able to use all these type of categories. So considering the uses of this toggle switches, we are using it in household lighting control. It can be also used in panel mounted control systems. It can be used in power switching appliances. And considering the reliability and the ease of use to make toggle switches, so it is used in residential and industrial electrical systems. Yeah, so that's all about toggle switches. So next we'll see what is meant by a slide switch. So slide switch is a switch uses a glider. So if you see the diagram, you will be able to understand. So this acts as an actuator, so which slides back and forth to make and break the contacts. So I think you will be able to understand this. So this figure shows the working of a slide switch, or SPDT, single pole double throw slide switch, so which is used to control the flow of current in a circuit. So note down the slide switch. So it is used to control on off operation of the circuit. while the other versions, for example, double poles and throws, etc., are used to divert the current flow from one direction to another in switching operations. So we have some basic representation. Uh, so considering the motion, the motion we call it as a linear motion. So which is actuated by sliding rather than toggling or rotating. When we consider the stable switching operation, it maintains position. So until manually the user gets changed. So compact design is very much useful to use the slide switch. So it is ideal for low profile or embedded applications. So we have some other common applications. So this particular slide switch can be used in consumer electronics. So more selection of power control is also possible here. So it can also be used in DIY circuits and prototyping. So very easy to integrate, and it can easy to handle. So embedded systems, we have a compact control interfaces. So slide switches are especially useful in scenarios requiring simple tactile control with clear mechanical feedback. So we have some other common applications like mode selection or power control. We can also use these type of slide switches in embedded systems to control the interfaces. And next we have slide switches that are typically useful in scenarios requiring simple tactile control with the mechanical feedbacks. So next we have push buttons. So it's also considered to be a type of a switch. So push buttons are momentary switches which are operated by pressing. So it can be given a pressure by pushing it for a while. So this mechanism for actuator inside, we can use it for close or open the circuit for on and off and on operation respectively. So there are generally no NC or double acting while which is used to control two different circuits. So here for example of push button switches, we call it comes under drills. It can be used in blowers and in doorbells. So push button switches are momentary contact devices that operate through temporary pressure applied by the user. So when a push button is pressed, the movable contact attached to the button uh, uh, will make a movement. So it connects the static or stable contact in series to make the circuit. So push button switches are momentary contact devices. As I told you, it when the button is pressed, the internal spring-loaded actuator drives the movable contact. So it connects with the stationary contacts, and thereby it completes the circuits. So when the pressure is released, the mechanism automatically returns the switch to its original state. Okay, so whenever you are releasing the pressure of a switch above, the spring mechanism automatically returns the switch to its original state. So this breaks the connection, and it restores the circuit to its default off or on position. So considering the momentary action, the push buttons are active only while it is pressed. So it gives a spring return mechanism. So it also ensures automatic reset. So the control is a little bit precise. So which is ideal for triggering short duration operations. And some common applications of push buttons are, it can be used in user input interfaces in embedded systems. It can also be used in start stop controls in industrial machinery. And we have reset buttons in electronic devices. So these buttons have various configurations. We call that configurations as normally open and normally close. So these are essential in system requirements, so which requires brief internal intentional user interaction. Okay, so next we'll move on to a limit switch. So in general, we'll see what is a limit switch. So limit switch is automatically or manually operated by an object in a control system. So it is a mechanical machine. So this is the representation of a limit switch. So we have two control systems where it is normally open, or we can consider that is normally closed. So the bumper arm in the switch is used as an actuator, and when the actuator or other comes into contact with an object, uh, it changes the direction of the flow of current. So it changes the position and operation of the circuit. So we are using this as an example instead of a push button. So here we have mechanical parts of a machine or other objects. So we have two poles which is used to control two separate circuits, and this particular limit switch, it breaks one circuit and it closes the other one at once. So this is a type of a switch. Already I told you it's a mechanical, electromechanical device which is used to control systems to detect physical presence or position of an object. So this type of limit switch detect the physical presence or position of an object. So it can be triggered either automatically by moving machine components or manually by external contact. So this switch typically uh, has a bumper arm, or we call that bumper arm as lever actuator, which when engaged by an object, it mechanically shifts internal contacts. So this action alerts the flow of current. So whenever there is a flow of current, it changes the state or behavior of the connected circuit. So it stops a motor, or it can reverse the direction, or it can initiate a new process. So that's the working of a limit switch. So mechanical actuation are the key characteristic features here. So it can be triggered by physical contact or motion. When we consider the other characteristics of a limit switch, it ensures a precise control in automation systems. Considering the discrete feedback, it is used for positioning sensing, and it can be used for safety interlocks. And we also have some other applications which can be used in robotics and CNC systems. So it limits the motion range. For example, we can consider industrial automation. So this type of switches can detect the end of travel positions. Limit switches are essential for safe and accurate and repeatable control in electromechanical systems. So these are the applications of a limit switch. And next, moving on to the flow switches. So flow switches are used to detect and control the flow of air or movement of liquids such as water, oil, etc. in the connected ducts and pipes. So we'll see in detail what is meant by a flow switch. Flow switches are nothing but it's an electromechanical device which is designed to detect and regulate the flow of air or liquids. So you'll be checking whether the flow of air or liquids is okay or not. So such as water, oil, or other fluids. So these switches play a critical role for identifying the flow rates within the within safe and functional limits. So when you consider the flow, when the flow exceeds, so when it goes above a threshold value, the spring loaded mechanism inside the switch triggers a snap action. So this snap action is very important. So this switch triggers a snap action. It also causes a metal arm to actuate a micro switch. So this is how it works. So this mechanical movement either makes or breaks the electrical contacts. So thereby it can alter the operational state of the connected system. And For example, like it can activate alarms, it can shut off pumps, or it can initiate other control responses. So considering flow switches, considering threshold based activation, the response to flow rate is changeable. So spring mechanisms ensures consistent actuation. So that is also a reliable part in mechanical field. And versatile installation is also possible here. So it is compatible with both metal and plastic piping. So there are some similar applications. Will be using flow switches in HVAC systems to monitor airflow in ducts, and we'll be using flow switches in industrial fluid control, managing coolant or lubricant flow. It can also be used in water treatment and irrigation. So it can also ensure proper distribution and safety. So flow switches are essential for automated control. It can also be used for safety interlocks and process optimization in fluid handling systems. So these are the basic working of flow switches. So next we'll move on to a float switch. So previously we have seen flow switch. This type we call it as float switch. So for example, we can see where we are going to use a float switch. So float switch is when the level of water falls below the designated line, the contact arm and the rod makes the contacts with the which also triggers the circuit. So a motor from pump considering the motor is activated, and the water tank again starts to fill the liquid. So now this kind of operation can be done in a float switch. So it is a floating switch that controls a circuit or machine inside a tank full of liquid. So it detects the level of the liquid and switches whether it can be on or off. So when the liquid level rises or it falls according to the requirement, this AC or DC motor is activated, and the water tank again starts to full the liquid. So similarly, when the water tank is full, the lever disconnects the terminal contacts, and it pumps automatically. So the motor pumps automatically. Uh, um, the motor pumps automatically the whole process, which is automatic, and it is simultaneous with the help of a flow switch, right? So so when the water tank is full, the lever disconnects the terminal contact, and the whole process is automatic, and it simultaneously help the mechanism with the flow switch. Okay. So when the liquid level rises, what happens? It defines a predefined threshold. So that float movement activates or deactivates the internal contact. So thereby switching the connected circuit can be performed by using either on or off. So this enables automated control of pumps, alarms, or other machinery based on real-time fluid levels. So so in float switch we have a passive mechanical operation. So these operation can have external power requirement for sensing. So reliable switching operation is also possible here. So which is ideal for high or low level detection. So it can also have early installation process uh, where simple integration can also be done easily. We have some applications like float switches, which are essential for safe, efficient, and automated liquid level. And industrial fluid management can also be done, preventing the overflow. And it can also be used in dry run conditions. So some other common applications we can have like wastewater systems monitoring, and it can also regulate fluid levels. It can also regulate fluid levels. So float switches are used for safe, efficient, and automated liquid level management control in both residential and in industrial environments. So next we'll move on to pressure switch. So pressure switch are used to sense and operate by air or gas under pressure in industrial applications. So the diagram shows how it is normally open, and it shows how it is normally closed. So the different types of pressure switches can be mentioned. For examples like metal bellow, piston type, and diaphragm operated pressure switches are widely used in pneumatic devices. And these type of pressure switches can also be used in hydraulic systems to measure a range of level of pressures. So the single pole or double pole pressure switches are operated by pressure detection elements, so which can also trigger the contract to open or close, um, to change the position of the system. So pressure switches are electromechanical devices, right? So which is commonly used in electrical or industrial automation, and in control systems. So when the when the pressure reaches a predefined value, the switch activates. So it can either open or it can close the electrical circuit. So it can also initiate control actions such as starting or stopping an equipment. So these switches come in various types based on their actuation. It can be done, as I told you before, it can be done in metal bellow, piston type, diaphragm operated. So each variant is tailored to have a specific pressure ranges and environmental conditions, making them essential components in pneumatic and hydraulic systems for monitoring and regulating pressure levels. So these are the basic ideas in joysticks. So they are mainly used in gaming control. So this directional actuation enables precise control over multiple functions. So it makes the joystick switches ideal for applications requiring maintaining the different inputs. So moving on to the next part, we have temperature and thermal switches. So this switches depend on temperature, where the heat sensing element is bent by the thermal expansion. So here we have a heating sensing element called as bimetallic strip. So when the temperature is reduced below the level, the bimetallic strip shrinks, so and it returns to the normal position. So this leads to make the contact, thus the contact are connected to close the circuit. So here we have some examples of a thermal switch. So thermal switches are NC thermal switch, and we are representing that as NO thermal switch. So it consists of a mercury glass tube, and here the thermal relays are also used here to control or overload protection of electrical machines. So thermal and temperature switches are used for heat responsive circuit control, and these devices can operate based on the temperature variations. So using a heat sensitive element, typically a bimetallic strip, it is used to control the electrical circuit. So when exposed to rising temperatures, this strip of say bimetallic strip undergoes thermal expansion. So this thermal expansion causes it to bend, or it deforms. So once when the temperature exceeds a preset threshold, so this mechanism leads to a break in electrical contact. So thereby opening the circuit, and it interrupts the power flow. So this is the basic working of a temperature or a thermal switch. So when you consider the operating principle, so bimetallic strip is composed of two metals with different expansion rates. So that we call it a sensing element, and temperature rises causes bending due to differential expansion, right? So that process we call it as trigger mechanism. So action can be taken. So contact is broken when the strip bends beyond a critical point. So these type of switches can be used in overheat protection in appliances, fire safety and alarm systems, HVAC systems, and these switches are valued for their simplicity, and it is very reliable, and the operation is very passive. So this makes them ideal for fail-safe thermal control in both consumer and in industrial settings. So these are the basic operations. So we have completed how the temperature and thermal switches operate. So next we'll move on to timer switch. So timer switches can be considered as both digital and analog timer switches. Which is used for time delay for specific appliances. So timer switches with the help of contactor and relays are used in power circuits. So it can also be used in water heater, timer. It can be used in central heating control vehicles. It can be used in sleep timers in the TV sets, etc. So this operates on timing mechanism. So the digital timers, for example, say ST01 timer or dusk dawn timers are used to control the automatic on-off operation. Uh, so, uh, so considering both the analog and timer switches, a time switch can be configured using the mechanical timer clockwork, where it makes or breaks the contact when the time runs out, and hence honor of the connected circuit from the supply. So time switches are mainly scheduled control for electrical circuits. So it is available both in analog and digital formats. So already I have told you this. So they operate by delaying or scheduling the activation or deactivation of a connected circuit based on a predefined time setting. When you consider in analog variants, yes, a mechanical clockwork mechanism can be used to track the elapsed time. So this process, or once the preset duration expires, the internal contact are either made or it can be broken. So either thereby switching the circuit on or off. So uh, time delay functionality is possible, and mechanical or electronic configuration can be set up. So this supports both traditional and programmable setups. So considering the time delay functionality, it enables a scheduled operation of devices, and based on energy efficiency, it prevents unnecessary power usage by automating control. So it also has varying applications, lighting automation, irrigation systems. It can also be used in HVAC scheduling, in industrial process timing, and so on. So these timer switches are essential for precision control. It can be used in automation. It can also be used in energy optimization across residential, commercial, and industrial domains. Till now we have learnt about timer switches. Timer switches are both also available both in analog and digital formats. Okay, so it is mainly designed to introduce a time-based control into an electrical systems. So they operate by delaying or scheduling the activation or deactivation of a controlled or the activation or deactivation of a connected circuit based on a predefined time setting. So that's all about today's lesson. So timer switches are essential for various control operation like automation, energy optimization across residential, commercial, and industrial domains. We have learned all the types of switches, mechanical switches, and so on. That's all about Unit 2. So your portion for your FAT 1 will be both Unit 1 and Unit 2. So try to learn all the portions. You can also you can also have your textbooks which is available in Google Classroom. So kindly refer those books. Thank you, students. Thank you for your time. We'll see in the next class, uh, where we'll be discussing Unit 3. Okay. So, so Unit 2 is over. Thank you all.